We see that Charles David Keeling followed the good advice of his advisor Roger Revelle at the Scripps Institution of Oceanography in La Jolla, California, and data started pouring in. In 1958, the first results came in from both observatories, Antarctica and Mauna Loa. CO2 levels stood at 310 ppm parts per million by volume. That means for every million bits of gas in the atmosphere, think of million particles of air, and then out of that 310 or CO2, tiny amount. We called it the trace gas, but it's a very powerful trace gas. It's like taking a big cup of tea and putting just 1 spoon of sugar, so it makes it very sweet, right? And similarly, you take this 1 million particles of air and put a little CO2 and it begins to warm the atmosphere. 310 of those bits in a million bits of gas in the atmosphere were CO2. In the 1700s, CO2 levels had only been about 280 ppm. ppm, you get used to this, parts per billion, but we don't say by volume all the time, but you know that it is. The jump didn't seem too significant at the time. It was far from an unsafe level still. But what if it was a trend and the levels kept rising? Remember, we already talked about variability versus trend, and we'll see this in the data again and mention the trend and the variability again. The jump didn't seem too significant. It was far from an unsafe level. But what if it was indeed a trend and the levels kept rising? Well, the South Pole Observatory closed, unfortunately, but Mauna Loa measured CO2 levels year after year. Soon it became clear the levels were rising ever higher. Again, outside of the Keeling's group and a small number of scientists, no one felt the alarm. And in fact, a few decades later, there were many interested parties like the oil companies and the energy companies that started to argue it was not alarming at all, that it was not a big deal at all. In the early 1960s, scientists, on the other hand, started using computers to predict Earth's climate in the future. Newer and more advanced models were developed over decades. What does it mean? There is the energy coming into the atmosphere, reaching the land and the ocean, and it is warming the land and warming the atmosphere and the ocean. And remember, we have energy deficit at high latitudes, energy surplus in low latitudes. We have to move the energy, and the winds are born, the currents are born, clouds are born, rain happens, snow happens, glaciers build, and so on and so forth. These equations that explain how the winds move and how temperature changes, they are very complicated. If you're old enough, you may have heard of it, the Navier-Stokes equations, except you also have to add Earth's rotation, because everything is happening on a rotating planet, and those who have done some physics may know that it's called a rotating framework. If you're young and you don't understand, don't worry about it. But the equations are so complicated that we cannot sit and solve them with a paper and pencil. If you have x plus y equal to 10 and y is 5, then what is x? These are easily done by hand, or sometimes you need a calculator. But when you want to solve mathematical equations, you have to do something to them and put them on a computer and represent the Earth in the computer and then let it do its magic. And in fact, this started only in the 1960s with the atmosphere being modeled, the land being modeled, and later the ocean being modeled, and then the model started to allow the oceans and the atmosphere to talk to each other, and so on and so forth. And guess what? Just a few years ago, who won the Nobel Prize for doing all this? Sukiro Manabe, who was at the Geophysical Fluid Dynamics Lab in Princeton, which is a lab of the National Oceanic and Atmospheric Administration of the US. told us in the 1960s and 70s that, folks, if we keep increasing the CO2, this is what will happen. And there was another person who was doing climate research as well, Klaus Hasselmann from Germany. Both of them won a Nobel Prize for their work in physics, and there was another person as well. So newer and more advanced models were developed over the decades, and Suki Manabe was one of the first ones to test them. Scientists put in information about the atmosphere, rainfall came out, and other factors from the past could be, you have to say when the volcanoes went off, how much energy from the sun is coming up, how the land is changing in terms of forests and urbanization, and how much CO2 we are putting in, and so on and so forth. So for years that already had a climate record, we can tell the models this is what we've seen happen on Earth. The glaciers were not modeled at the time, and so on and so forth. Many details. It's like sitting in a car. The car is running. You don't necessarily know exactly what's happening, but you know that many things are happening. The fuel is going in and it is being burned, or the battery is sitting there and it's getting charged before you start, and then the battery is driving the shaft, and the shaft is turning the wheels, and your dad is driving it and steering it safely, or your mom or your brother or your sister, and so on and so forth. So computer models are like that, big computers with lots of equations inside that are producing all these things. Okay, so let's look at some data. We are now looking at more recent data. So this is the CO2 mole fraction, is another word in terms of ppm. So out of 1 million moles, you have 300 and 400 and some moles here. So 310 ppm when Charles Keeling started, but look at this, we already had David Keeling started, and look at this, we were already 413 or so by 2020, and we keep going up, and this is the latest one I took from NOAA. You can go, when you're listening to this, you can go online and see what is the latest, right? We're showing two things here. The red line is showing monthly average CO2, January, February, March, April, May, and so on for each year, and then they do something to look at the measurement and see how the seasonal cycle has to vary from the last 7 months. So that other smooth line is doing some corrections, but this up and down, what is called a sawtooth pattern, already tells you something that you must already know, or you may be already guessing it, or you may have heard about it. When the CO2 goes up in the atmosphere at Mauna Loa, what is happening? That means somebody is releasing CO2 in January, February, March, and then it begins to go down in, let's say, April, May, June, July, and then September, October, November, it starts to come back up. What is happening? What is happening on Earth that can take up CO2 and release CO2 based on which season it is? Of course, it is the plants, the forests, and so on. So when the sun comes up, photosynthesis starts, and CO2 begins to go into the plants, so it begins to decrease. So if you start in January, photosynthesis is down and leaves have fallen for many trees, and sun has gone to the other hemisphere. For us, it is the southern hemisphere that sun is gone into, and northern hemisphere is not photosynthesizing as much, so you have CO2 increasing, and then sun comes back across the equator, and plants wake up and start photosynthesizing and taking down CO2, and then when the summer is over and fall comes, and beautiful fall colors appear in many places at high latitudes, or even in the mountains of the tropics, and then you begin to see CO2 increasing because photosynthesis is going down, and so on. Okay, so it's nice seasonal cycle. But what is happening? It is going up and up and up. There is always a seasonal cycle, and year to year the CO2 can change, because one year more may be going into the ocean, in another year maybe there are lots of wildfires that are releasing CO2, or maybe people are cranking away, producing things, buying things, burning fossil fuel, traveling around and consuming things that produce CO2, and then CO2 may go up. Or pandemic may come, COVID-19, and there are travel restrictions and factories are closing and restaurants are closing. People are consuming less and CO2 may go down. So you may see some signals here of the COVID, like a little dip here, and then we are going back to normal again by the time you see 2024 came, because we forgot about the pandemic and we are back to consuming as usual. Let's now go back to when David Keeling started and look at the mole fraction. We started around 310, as we said, and this up and down is going on, but the CO2 is increasing and increasing and increasing, right? So now you have to think, if it keeps increasing, what happens? You know that it's the greenhouse gas, the strongest or the most abundant greenhouse gas, and it's going to keep trapping more and more of the thermal energy that is trying to go to space. So blanket is getting thicker and thicker, and the greenhouse effect is getting stronger and stronger, and more energy is accumulating in the system. Warming, glacier melting, albedo changes, positive feedbacks or vicious circles, which we'll talk about in the next section. And it's not good news. Just as I'm recording this, yesterday I did a TV interview and many newspapers were calling and asking, why is Delhi reaching 52 degrees centigrade, potentially the highest ever recorded temperature in Delhi in the last, whatever number of years in which we have been measuring temperature over Delhi. Heat waves are occurring everywhere across the planet this year, and 2023 was a very warm year because you have CO2 that continues to increase. We are increasing renewable energy, solar energy, wind energy. We are making cars more efficient, more electric vehicles are coming in, but we are still burning fossil fuels at a much faster rate than we are reducing CO2 or reducing our emissions. Okay, so by the 2000s the models proved accurate again and again. They not only predicted Earth's climate future, they explained Earth's climate past as well, because if the model is saying something will happen in the future, then you have to say, did the model accurately say what has happened in the past? Otherwise, why should I trust it? Then you say, well, it did. We looked at the past in the models and it did a good job, and each model pinpointed greenhouse gases as the cause for recent warming. What is each model? Well, many groups build models. In US there may be tens of groups it takes a lot of people to build these models. India has some models, China has many models, Australia, Europe and South America and so on. There are many models. People love to build models. They are slightly different. You don't have to worry about the details, but you can look at all the models and say they all say the same thing, that increasing greenhouse gases are causing warming. So we'll leave this here and come back and continue this discussion. Should you get scared? Well, you have to watch out what's happening and ask your teachers, parents, siblings, neighbors, friends about what can be done and who's doing what and what do you want to do about it as you grow up. Don't get scared. You just say, I'm going to solve this problem. I'm going to make more efficient everything. I'm going to make produce things without producing so much carbon. I'm going to build efficient renewable energy. Renewable means something that can be, fossil fuels are not renewable, right? We take them out, we burn them. It takes millions of years to form them, but we can burn it in a day, so they are not renewable. So renewable means sun is coming in, sunlight is coming in every day, capture the energy, next day we have more energy coming in. So renewable energy is solar, wind, hydroelectric, nuclear, and so on, wave energy, and so on and so forth. See you in the next podcast to continue this discussion about measuring greenhouse gases. We will mostly talk about CO2, but there are ways to measure methane, N2O. There are satellites flying measuring everything. There are planes and drones and automobiles are measuring things, and instruments are put everywhere, not just Mauna Loa, in the Himalayas, in the oceans, to measure these things. So we'll come back and continue. Okay.